Every single piece of tech we rely on, from the phone in your hand to the battery in an electric car, it all started its life as a mineral, deep inside the earth. For centuries, finding these crucial materials has been a mix of hard science, sheer grit, and, let's be honest, a little bit of luck. But what if we could bring a powerful new tool into that search? Today we're diving into how artificial intelligence is turning the ancient science of mineralogy into a full-blown high-tech treasure hunt.
So, here's the big challenge. Our transition to green energy, it demands a massive, and I mean massive, supply of critical minerals. The problem is, all the easy-to-find deposits, well, they're pretty much gone. We have to look deeper, and we have to look smarter. This isn't just about finding more rocks anymore. It's about securing the very building blocks of a sustainable world. The real question is, can AI be the guide we need to find those treasures hidden deep within our planet?
So here's our game plan. First, we'll get grounded in the fundamentals of mineral science. Then, we'll see how you can actually teach an AI to think like a geologist. After that, we'll look at a pretty radical new scientific method for discovery. And finally, we'll explore what the future of exploration looks like when humans and AI actually start working together.
Okay, before we get to the robots, we gotta understand the rocks. And that all starts with the foundational science of mineralogy.
Simply put, mineralogy is kind of like learning the language of the earth. It's the science of figuring out what minerals are, how they're built atom by atom, and what their very presence tells us about the history and the potential of a piece of land.
And believe me, this is a really complex language. Scientists have to study everything from the super precise angles of a crystal structure, that's crystallography, all the way to how light literally passes through it. Every single one of these concepts is another piece of the puzzle, a clue that geologists use to read the story that's written in stone. It's a massive body of knowledge built up over generations.
And all this knowledge, it isn't just for a textbook. As this quote really drives home, it's a practical, absolutely essential encyclopedia. So for any AI to be even remotely useful, it can't just know the basics. It has to learn from this same deep, encyclopedic well of information that humans do.
So, how in the world do you teach a machine to read rocks? Well, you start by showing it a ton of examples, just like you would with a human student. And this is where the really big breakthrough is happening right now.
So you start with the classics. First up on the curriculum, granite.
Now, granite isn't just one thing. Think of it more like a very specific recipe of minerals. To officially be called granite, a rock has to have this precise blend of feldspars, quartz, and micas. The AI doesn't just have to learn the ingredients, it has to learn the exact proportions.
Okay, next up, the AI has to study sandstone. And this is where things start to get a little tricky.
Because see, sandstone uses some of the same ingredients as granite, but the recipe is totally different. Here, it's almost all quartz, with way less feldspar. It's these subtle little shifts in the percentages that completely change the rock's identity, and that's a super important lesson for the AI. And finally, for its last big test, the AI meets limestone, which is a whole different kind of puzzle.
Limestone's identity is almost entirely defined by one single dominant mineral, calcite. So in this case, the AI's job is to recognize that overwhelming presence while also picking up on the other minor minerals that tell a more detailed story about where this rock came from.
Okay, so how does it all come together? Well, researchers built this amazing automated pipeline. First, you take a rock sample and you analyze it with something called Raman spectroscopy, which is basically a fancy way of using light to get a unique molecular fingerprint of all the minerals inside. That fingerprint data then gets fed to a deep learning model, which has been trained to recognize all those patterns. And finally, a knowledge system, which has been programmed with those recipes we just talked about, makes the final call. Is it granite, sandstone, or limestone?
And the results? They are absolutely staggering. In that first critical step, just identifying the individual minerals, the AI model hit an accuracy of over 98%. It has basically learned the fundamental vocabulary of geology with near-perfect recall.
But, identifying a rock that's already in your hand is one thing. Finding a deposit that's hidden under miles of earth, that is a whole other challenge. For that, we need AI to do more than just classify things. We need it to help us think like a scientist.
And here's the bottom line, the old way just isn't working anymore. As Stanford's Jeff Cares points out here, even with demand for minerals going through the roof, the business of finding them is incredibly difficult and expensive. We're drilling more holes and finding less stuff. The industry is losing money because it's chasing too many dead ends.
A big part of the problem is this old deterministic approach. It takes all this complex geological data and tries to spit out a single best guess map of what's underground. But that's just one possibility out of, well, a whole lot of them. This new AI-powered method is what we call stochastic, which is just a way of saying it embraces uncertainty. Instead of one map, it generates hundreds of different plausible models of what could be down there. And that forces scientists to confront all the possibilities instead of just betting everything on a single outcome that might be wrong. This whole new way of thinking has been formalized into something called the Popper-Bayes protocol. And what it does is it basically flips the traditional scientific method on its head. Instead of looking for data to confirm a hunch you have, the real goal here is to actively try and break your own hypotheses with new evidence. You come up with multiple ideas, you test them like crazy, and only the toughest, most robust models survive. It's a system designed to kill bad ideas and false positives as early as possible.
So, all of this brings us to the future. And it's not a future where AI replaces geologists. No way. It's a future where AI becomes their single most powerful partner. This really breaks it down perfectly. Humans are brilliant at the creative, big picture stuff, dreaming up the geological story of how a deposit might have formed in the first place. AI, on the other hand, is brilliant at the heavy lifting, crunching massive data sets without any of our human biases, running thousands of simulations, and measuring uncertainty in a way our brains just aren't wired to do. It's the ultimate team-up.
And this right here is the payoff. Exploration is all about reducing scale. You start with a massive area, like this huge map of Canada, and you have to somehow zero in on a tiny little patch of ground that's worth drilling. By running through countless models and trying to break all those hypotheses, AI helps geologists do this way more efficiently. It points them toward the most promising targets and saves millions of dollars in wasted effort.
You know, by combining that deep foundational knowledge of mineralogy with an AI's power to handle huge complexity and uncertainty, we are fundamentally changing how we explore our own planet. It really makes you wonder, with this brand new scientific partnership, what vital resources are we on the verge of discovering, hidden just below our feet?